So if we look at the equation, is delta G is equal to delta H minus T delta S. So somehow it has a nice tone to it, so it's quite simple to remember. So important to understand the terms because before we do any analysis. So delta G is the Gibbs free energy. Okay, so Gibbs free energy. And the important thing, rather than like understanding too much the meaning of it, I mean, it is at the end about the energy that the overall energy in a reaction. So is extra energy required for this reaction to occur or not? Okay, so the important thing though is the unit is measured kilojoules per mole like any energy. Delta H, enthalpy, and would be the enthalpy of a specific reaction. Okay, of the reaction that we are taking into consideration. And that would be also kilojoules per mole. And then we have the temperature. Temperature would be measured in Kelvin always. Because entropy, so entropy is, we will look at the definition. I want to notice the units first because it's joules per Kelvin per mole. Very often those are actually given in a question, so we don't even need to remember them. But it's so important to notice them because there will be conversions required, plus the rearrangement can help us, or the units can help us ensure we do the correct rearrangement. Okay, so the rearrangement that needs to be done, enthalpy and entropy, they need to be the same units. So we need to either convert it into kilojoules or joules. I would do it always to kilojoules because the Gibbs free energy is also in kilojoules. So we'll simply divide it by 1,000. And then, well, normally we measure the temperature in centigrade. So Kelvin is always plus 273. Okay, so those are important because easy marks to miss if we don't notice the units. But one thing that and important analysis to do about this question, about this equation, is what this actually means. Because the Gibbs free energy, it tells us about if a reaction is spontaneous or feasible. So it tells about the feasibility. Because if it's negative, the reaction would be spontaneous. And let's think about why is that? So positive would be non-spontaneous, like this. And if it's 0, is a reaction on equilibrium. Okay. Spontaneous, let's think about why. So it's an energy and it's negative, which means that energy would kind of be released. Think about exothermic reactions that energy is released from this reaction. So this means that there is no extra energy that is required at that specific temperature, very important, for the reaction to actually take place. That's why if we remember, negative means exothermic, means energy is released, which means that we don't have to put extra energy for this reaction to take place, which means that the reaction would be considered spontaneous or better feasible. Yeah, because that's what it means. No extra energy is required for it to occur. Okay, and now we will look at the combination of signs because that's where you can get a bit mathy. So keeping in mind this equation, now let's do a bit of analysis. So the application, the calculations are relatively simple, but there are a few things, of course. It's a bit more complicated when we have to do other analysis of the equation or predict if a reaction is spontaneous or not, just by thinking about not actual values, but like signs. And then if there is any graph to interpret. Okay, but the graph normally would be like an exam question where you are given a bit of background enough to understand what is happening. But what I would like you to think about now is the signs and when a reaction is spontaneous or not. So let's say that we have our delta G, so let's say negative, positive. Exactly, we want it to be negative always. But I would like you to think about what are combinations of this, and the temperature, the options are any above a certain temperature, let's say temperature above T1, let's call it, T1 above a certain specific temperature, yeah, or T1 below a certain temperature, okay? When would the reaction be feasible? So what I'd like you to do, what you need to do is think about the combinations of the values, or specifically the signs of enthalpy and entropy, and how this will make the delta G negative. Then we can think about the meaning of each number. So the combination that will give a negative and always negative are an exothermic reaction because that the value of delta H is negative. So this can only make the delta G more negative. Then the thing to think about is always this whole term and make this whole term as negative as possible. But this means that, so because we have a minus in front, the delta S, we want it to be positive. So positive entropy, we will see what that means, but it means an increase in disorder of the reaction. So this means either more particles that are formed or change in physical state into a more disordered one. With those two combinations, the temperature can be any, and the reaction will always be spontaneous. It's in Kelvin, so we don't really have a negative temperature. Yeah. Okay. The exact opposite will make a delta G always positive. So an endothermic reaction, because it's a positive sign, negative entropy, and at any temperature, doesn't matter how big or how small. Okay, and then actually, no, I want you to think about not the zero because at equilibrium, it doesn't matter. What I want you to think about is what if we have the other combination? So if the only combination that is missing is actually two combinations, both negative and both positive. At which temperatures, or better, how do we discuss the temperature? Oh. So when we have these combinations, the temperature doesn't have an effect because, so if we have delta H is positive and delta S is positive, we know that the minus T delta S, I'm going to write here on the side, the minus T delta S term is going to be negative always because the delta S, it's positive. So this whole term will always be negative. However, to make the delta G negative, we want the temperature, to be bigger, or above a certain temperature, in order to make the T delta S a bigger term, bigger in value compared to the delta H. Because this, it would be, so the temperature has to be, so we'd say temperature higher, temperature 1 higher than a certain temperature to make this negative. And this is because this term minus T delta S would be larger than the delta H. That's important. So this means that I would say higher temperatures, this reaction could still be spontaneous. While for the one below, if we have the other combination, it would be exactly the opposite. If we have a temperature 1 lower than a certain temperature, which, it's something we can calculate, but in this case, we want this minus T delta S to be smaller than the delta H, so that the term would always be negative to make it spontaneous. That's where the temperature matters. And actually, the calculation for when the reaction will be spontaneous is just rearranging using T. Because if we consider a delta G to be 0, we know that above a certain temperature, it would be negative because it would be this negative term. So above a certain temperature, the delta G would be, or the reaction would be spontaneous. That's how also the question could be structured in an exam. So we would simply rearrange it by doing delta H divided by delta S. That would simply be the rearrangement to calculate the temperature, considering this being 0. So, so that's relatively simple. So above this temperature, the reaction will be spontaneous. That's why the temperature sometimes matter when we have these combinations. So, but this is to understand a bit, and at the end, it's very simple, like plus or minus, very simple math. We can also put some numbers in if you're not sure about the value that we get at the end, just to make it clear for you. But I would say you could have some questions where you have to explain this, or you have to, if I find some exam questions, I will put them on. Okay, but this is a type of description that, or a type of open question that requires a bit more analysis rather than just calculations. Okay. So one of probably the most challenging question you could get, because as we saw, the math, the science analysis is not too complicated, but when we have to apply this to something like this, a graph, it can definitely get a bit more challenging. So let's think about the graph. We have the equation. It's a relatively simple linear equation. So the thing to think about, also considering straight lines, we always need to think about dy is equal to mx plus c, so the linear equation. Keeping that in mind, let's read this question and let's do it together, which is for 4 marks in total. Okay. So keeping in mind this equation, so y is moving, y is equal to mx plus c. We need to think about, okay, y, we have clearly that delta G. So let's write it here, is equal to, what do we have at x? X would be plus T. So it's the temperature positive value. So what values are we missing? We are missing the negative, the delta H, and the delta S. So we know that the gradient, yeah, must be whatever is attached to whatever is timed to the x. So we have minus and the delta S. So the gradient would be minus delta S, and the plus C, which is the intercept with the y-axis, would actually be whatever it's missing in this equation. So it would be delta H. If you think about it, also makes sense because delta H also has a unit of kilojoules per mole, and negative value, so it would be an exothermic. So the important thing is to keep in mind this linear equation, and then try to combine that linear equation, or try to think about what how the equation that you have, in this case the entropy Gibbs equation, it fits into the linear equation. But to summarize this for 4 marks, so we can say, well, that P is the intercept, so it's going to be delta H intercept. So the value of delta H. We said the gradient, so M would be minus delta S, yeah, because we understood that from the equation. And then Q, very good, would be the temperature. It would simply be the temperature for the reaction to be feasible. Yeah, so the temperature which the feasibility changes, or the temperature which the reaction is feasible. So let's write Q would be just the temperature for delta G to be negative, so to be feasible. Okay, so that's the analysis to do, and it is a bit of an application question, so it's more of a bit mathy rather than understanding apart. Well, we need to understand the feasibility, yeah, but notice how simple math applied to this equation.